Hello guys, Assalamu alaikum, Bismillahir Rahmanir Rahim. Today we are going to start chapter 1 of class 9, which is Matrices and Determinants. So first thing first is, what is a matrix? So let's define a matrix first. You can say a rectangular arrangement, a rectangular array or arrangement of real numbers within square brackets, is known as a matrix, is called a matrix. Okay, matrix is the singular form of matrices. So the plural of matrix is matrices. You can write here also, plural is matrices. Okay, and singular is matrix. So a rectangular arrangement or array of real numbers. What is a real number? A real number, I will give you the link in the video. You can see in chapter 2 I have defined what is a real number. Within square bracket is called a matrix. For example, we have a matrix A. You can say its elements are 1, 2, 3 and 4. So this is a matrix. So, or you can take another example. B is equals to A, B, C and D. 1, 2, 3, 4, 1, 2, 3, 4 or A, B, C, D. These are called elements or entries of matrix, right? And a matrix is conventionally denoted by capital letters A, B, C, D, whereas its elements you can write with small a, B, C, D or 1, 2, 3. All these are real numbers. Now you can see this is a special arrangement of numbers in the form of rows and columns. So here we have, see, this is called a row. Let me change. So a matrix has m number of rows and n number of columns. It may have many number of rows and many number of columns. So in this matrix A, we have, let me change the color. So for example, in matrix A we have one row, and this is second row, 2 rows and 2 columns. 2 columns, 1 and 2. Similarly, in B also we have 2 rows and 2 columns. So what is number of row in A? So 2 rows, so these are called number of rows or rows of matrix, and this blue color is called columns of matrix. So in matrix A we have 2 rows and 2 columns. Similarly, in B also we have 2 rows and 2 columns. Yeah, it may be different, like for example I will write another matrix C whose elements are 1, 2 and 3. So how many rows are there? There is 1 row only. We can see this is 1 row only. So write here 1. And how many columns are there? 1, 2 and 3. So 3 columns. So next topic is, what is order of a matrix? So this is the order of a matrix. Number of rows times number of columns is called the order of a matrix. So now you know what is a matrix. A rectangular array or arrangement of real numbers within square brackets is called a matrix. And a matrix is denoted by capital letters A, B, C, D, and whereas its elements are denoted by either small a, b, c, d, or the real numbers 1, 2, 3, 4, or 0, minus 1, minus 2, minus 3, as you like. And the plural of matrix is matrices. Now we will see what is the order of a matrix. So order of a matrix. Order of a matrix is equals to number of rows times number of columns. Number of columns. For example, the order of A is in matrix A. So what is order of A? Order of A, we have 2 rows and 2 columns. So 2 times 2. We will not say 2 times 2 is 4. Just this, like this we will write. This is number of rows and 2 is number of columns. What is order of C? Order of C is, you can see here, 1 row and 3 columns. So 1 into 3 is the order of C. So like this, if a matrix A is having m rows and n columns, then we can say the order of that matrix is m times n. If there are m rows and n columns of a matrix. What is equal matrices in this exercise? Equal matrices. Equal matrices. Why I am not writing here matrix? Because it is more than one. Obviously, we have to compare one matrix with the other matrix. Then it will be matrices. So equal matrices. So 2 or more than 2 matrices can be equal. So here let's see, we can say 2 matrices are said to be equal. If and only if their order and corresponding elements are same. Same or equal. So how we defined equal matrices? 2 matrices are said to be equal if and only if their order and corresponding elements are same or equal. Means there is an and means both should be there, both conditions should be there. Their order should be same and corresponding elements should be same. For example, Let's see, there is a matrix A whose elements are 1, 2, 3, 4, 5 and 6, and there is another element B, and there is another matrix B whose elements are again can I write 1 as 2 minus 1, which is 1, yeah, 2 and 3, 4, can I 4 as it is, okay, 5 I can write as 4 plus 1, 4 plus 1 is also 5, and 6 is 6 here. Now what is the order of A? Order of A is 2 rows, we have 2 rows and 3 columns, so 2 by 3 is the order is same. Let's check here also 2 rows and 3 columns, so 2 into 3 we have 2 rows and 3 columns, so order of both matrices are same. Now we have to see corresponding elements are same or not. So corresponding elements means 1 here and here also we have 1, 2 minus 1 is 1, here we have 2, here we have 2, 3 is the element of first row and third column, so here also 3 is same, 3 is same, 2 is same, 1 is same. Similarly here we have 4, so here we must have 4. Similarly 5 and 5, 4 plus 1 is 5, 6, and here we must have 6. So both conditions must be satisfied. The order of two matrices must be same, and the corresponding elements means at the same position. If there is an element of first row and first column, in the second matrix also it should be at the same place, that is first row and first column element. Let's see some example of the matrices which are not same, which are not equal. So let's have C is 1, 2, 3 and 4 elements of C, and its order is 2 rows and 2 columns. 2 rows and 2 columns. Consider another matrix D, 1, 2, 3 and 4, 5, 6 I will write here. Now its order is 2 rows and 3 columns. 2 rows and 3 columns. 2 rows and 3 columns. Now you see corresponding elements, 1 is here, 1 is here, 2 is here, 2 is here, 3 is here, 3 is here, 4 is here, 4 is here. Corresponding elements are same, but the order is not same. The order of C is 2 cross 2 and the order of D is 2 into 3, so which is not same. Order is not same, so C is not equals to D, because order of C is not equals to order of D. Similarly, let's take another example. If we have E matrix 1, 2, 3, 4, its order is 2 by 2, and there is another F matrix, its order is 1, 2, 3 and minus 4. Now you can see order is same, 2 into 2 and 2 into 2. Let's check the corresponding elements, 1, 1, 2, 2, 3 is here, 3 is here. Here we have 4, but here in F we have minus 4. So the corresponding elements of E is not equal to the corresponding elements of F. All elements should be same, then it will be same or equal. If any one element is not same, then we will say these two are not equal. So E is not equals to F. Even the order is same, but the corresponding elements is not same. 4 is not equals to minus 4 here. 4 is not equals to minus 4 here. That's why. So both conditions must satisfy for equal matrices. Order must be same and corresponding elements must be same. Okay guys, let me conclude till here. We have seen what is a matrix. A matrix is an arrangement of real numbers within square brackets, and we have a matrix in the form of rows and columns. There are rows and columns in a matrix, and the number of rows times number of columns is called order of a matrix. And then we have seen how two matrices are equal if their order is same and their corresponding elements are same. Now we'll do exercise 1.1. In exercise 1.1, question number 1 is find the order of the following matrices. So you know how to find the order of a matrix. It's so easy. So here we have, you can see in question number 1 we have one row, these are rows, and how many columns we have, you can see 1 and 2 columns and 2 rows. So first of all you need to write here 2 rows and 2 columns. So this is the order of A. Order of A is 2 into 2. So question number 1, order of A of matrix A is 2 into 2. Similarly, you can write answer for all. So 2 rows and 2 columns, 2 into 2. Here for C, you have 1 row and 2 columns, 1 and 2. In D, 1, 2, 3, 3 rows into 1 column. In E, we have 1, 2, 3, 3 rows and 1 and 2 columns. We have 1 row and 1 column. 1 into 1 is the order of F. So in G, we have 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. So we will write 3 into 3. Similarly, in H, we have 2 rows and 1, 2, 3 columns. So 2 into 3 is the order of H. Okay. Now in question number 2, which of the following matrices are equal? So first of all, you know the definition of equal matrices. What is that? The order must be same. So let's find out the order of all matrices, and if there is any simplification in any matrix, we can do that one also. So 3, the order of this A is 1 into 1. The order of B is 1 row and 2 columns, 1 into 2. The order of C we can write like 1 is 3. So order is 1 into 1. Order of D is 1 row and 2 column. Order of E is 2 rows and 2 columns, and order of F is 2 rows and 1 column, 2 rows and 1 column. Similarly, G we can modify. 3 minus 1 is 2 and 3 plus 3 is 6. Now you can write its order, which is 2 into 1. Order of H is 2 into 2 again, and I we can modify. 3 plus 2 is 5 here. Now you can see its order is 1 row and 2 column. Similarly, J we can modify. 2 plus 2 is 4 and 2 minus 2 is 0, and 4 plus 2 is 6, 2 plus 0 is 2. Now what is the order of J? 2 rows and 2 columns. Now we can see the corresponding of A and C. A is here 3 and C is 3, and order is also 1 into 1 and corresponding is also same. So we can say A and C are equal matrices. A and C are equal matrices. Now check B. B is 3 and 5 and order is 1 into 2. Can we see 3 and 5 anywhere? Yeah, I. B and I, both matrices are same. Corresponding elements also, B has 3, and here in I we have 3, and then we have 5, and here also we have 5, and the order is also same, 1 into 2 and 1 into 2. So B is equals to I. You cannot say it is equals to D, even the order is same. D is also having order 1 into 2, but the corresponding element is not same. Here we have 5 and 3, but in B and I we need 3 and 5, not 5 and 3. Okay. Now A done, B done, C done. D, 5 and 3 we cannot see anywhere. So E 4062 and order is 2 into 2. E and you can see H also, both are same, E and H. Not only E and H, J is also same. So J, you can see this one also. So E is having 4062, H is also having elements 4062 and J is also having 4062, and order of all these three are also same. So we can say E is equals to H and equals to J. All three matrices are same. Then F is equals to, you can see 2 and 6. F is equals to G. G is also having 2 and 6, and the order is also same. Now A, B, C done, D is not equals to any matrix, and E done, F, G, H, and I also done, and J also done. Now let's do question number 3. Question number 3 is saying find the values of A, B, C and D which satisfy the matrix equation. So we have to find the constants A, B. We have to find the value of A, B, C and D. A matrix equation is given, and there is an equal sign also. You know that in equation we must have equal sign. Now these two matrices are equal because there is an equal sign, equality sign is there. So we have to see its order. Its order is same? So order is 2 into 2 and 2 into 2. Yeah, order is same. 2 rows and 2 columns. Now their corresponding elements must be same because these two matrices are equal. So we know the definition of equal matrices. Their corresponding elements must be same. A plus C must be equals to 0 because these are equal matrices. Similarly, A plus 2B must be equals to minus 7. Similarly, C minus 1 must be equals to 3, and 4 minus 6 must be equals to 2D of this element, right? Now we can write here, this implies that A plus C must be equals to 0, and you can write C minus 1 must be equals to 3. You can take columns first or you can take rows first, as you like. A plus 2B is equals to minus 7, and 4D minus 6 is equals to 2D. So we have these 4 equations. Now you need to find A, B, C and D. Any constant you can find first, whatever is easy. You can see here C is equals to 3 plus 1. Add 1 on both sides or bring 1 this side. It will change the sign, so 3 plus 1 will be 4. So this C you can use here in equation 1 to find A. So put C equals to 4 here. So A plus 4 equals to 0. So A equals to negative 4. So this is our A, and this one is our C. This C I have used here. Similarly, we can find D easily here. First 4D is equals to, Similarly, here we can find d easily. So subtract 2d from both sides, or bring this d here. When 2d will come this side, it will be minus 2d, and take 6 to the right hand side. When it will go there, it will be plus 6. Actually, we are adding 6 on both sides and subtracting 2d from both sides of the equality. So 4d minus 2d is 2d is equals to 6. Now you can divide with 2. So d is equals to 3. So we got d also. Now b left. So we can use here a, use a equals to minus 4 here. So minus 4 plus 2b equals to negative 7. So 2b equals to negative 7. Bring 4 this side, so it will be plus 4. Or you can add plus 4 on both sides. So 2b is equals to minus 7. 4 is minus 3. So we have b minus 3 by 2. Divide 2 by on both sides. So b is minus 3 by 2. So this is your answer, A, B, C and D. You can check your answer also by putting these value of A, B, C in the question. How? In exam, no need to verify, just we can verify here. So what is the equation? Here you can put, you can see here, if you will use A, B, C, A is, what is A? A is negative 4 plus what C? C is plus 4. A is negative 4 plus 2. What is the value of B? B is minus 3 by 2. Similarly, C minus 1 means 4 minus 1. And we have 4, D is 3 minus 6. I am using the value of A, B, C in the given question, and the equation equals to 0, minus 7, 3 and 2. What is D? D is 3. So you can see now here. So now here we have 4 minus 4 is 0. And 2 cancels the 2, minus 4 and minus 3 is minus 7. 4 minus 1 is 3 here. 4 times 3 is 12. 12 minus 6 is 6 is equals to 0, minus 7, 3 and 2 times 3 is 6. Now you can see both matrices are same. So we have verified our solution. Thank you guys. Have a nice day. See you in the next class. Assalamu alaikum.